Welcome, my friends. Consider the points M and N on the plane. The point M has the coordinates -9, 9, and the point N has the coordinates -1, 2. The shortest distance between any two points is equal to the length of the straight line that joins them together. So if we can find the length of the line that joins points M and N together, we will have the distance between the 2 points. So how do we find the length of this line? Well, if you know anything about right triangles, you might have an inclination of how to solve this. We can create a right triangle out of the 2 points, with a height equaling the vertical distance and a base equaling the horizontal distance. The height is the difference in the y-coordinates, 9 minus 2, which is equal to 7. The base is the difference between the x-coordinates, -1 minus -9, which is the same thing as -1 plus 9, which is +8. If you remember the Pythagorean theorem, it says that the square of each leg added together is equal to the square of the hypotenuse of your triangle. We label the legs as A and B, and the hypotenuse, the side opposite the right angle, as C, so that A squared plus B squared is equal to C squared. We know A and B are 7 and 8, but we don't know C. That's what we're trying to find, the distance between points M and N. Note that it wouldn't make a difference if you swapped around A and B, but C must be the hypotenuse. Plugging into the formula, we have 7 squared plus 8 squared is equal to C squared. This simplifies to 49 plus 64 is equal to C squared. 49 plus 64 is equal to 113, so we have 113 is equal to C squared. Taking only the positive square root of both sides, since the negative square root wouldn't really make any sense for distance, we have C is equal to the square root of 113, which is the distance from point M to point N. Now, if you don't like drawing triangles every single time, you don't necessarily have to. There is a formula called the distance formula, which takes everything we did and puts it into a nice formula. The distance formula says that the distance d between 2 points x1, y1 and x2, y2 is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Hopefully you can recognize what this formula is doing. x2 minus x1 and y2 minus y1 are just finding the base and the height of the triangle, just like we did. And these values are squared, just like they were in the Pythagorean theorem. In the process of solving for c, we had to take the square root of the square of each of the 2 legs, which is what this formula is telling us to do. Let's try another problem where we use the distance formula instead of drawing a triangle. Here we have the points Q and R, where Q is equal to -2, -5, and R is equal to 5, 1. Let's think of Q as point number 1 and R as point number 2, so that we have these values for x1, y1, x2, and y2. Plugging into the distance formula, we have the square root of x2 minus x1 squared, which is 5 minus -2 squared, plus y2 minus y1 squared, which is 1 minus -5 squared. Subtracting negative numbers is the same thing as adding numbers together, so we have 5 plus 2, which is 7, and 1 plus 5, which is 6. Squaring both values, we have 49 plus 36 inside the square root. 49 plus 36 is equal to 85, so our answer is the square root of 85. The distance from point Q to point R is the square root of 85. What if, instead of wanting to find the distance between the 2 points, you wanted to find the midpoint? That is, the coordinates of the point directly in the middle of the 2 points. It's actually relatively straightforward. All you have to do is find the average of the x-coordinates and the average of the y-coordinates. The formula is midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Let's calculate the midpoint from the same 2 points, Q and R. We have -2 plus 5 over 2, comma, -5 plus 1 over 2, which simplifies to 3 over 2, comma, -4 over 2, which simplifies yet again to 3 over 2, comma, -2. That means that the point 3 over 2, -2, is exactly in the middle of the 2 points Q and R. Alright, my friends, that wraps up our video covering the distance formula and the midpoint of 2 points.